Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope all of you are doing good. Just quickly let me know, people in the chats, if I'm audible and visible to everyone. Quickly let me know in the chats if I'm perfectly audible and visible to everyone. Hello Aisha, hi Ashwarya, hello Nandini, hello Mutahar, walaikum salam, hello Sakir, hi Gaurav. Welcome back everyone, welcome back. Just quickly let me know in the chats if I'm perfectly audible and visible to everyone, my dear people. Yes, perfect. Hello Zahid, hello Aisha, hello Ishita. Welcome back, welcome back. I'm doing good, thank you. So people, as you all must be knowing, tonight we are going to have a session on the most expected questions from the chapter mole concept. And this session particularly is for the ones who are going to write the JEE in 2022, right? Well, 2023 people, 2024 people can also watch it, no issues at all, right? So before starting tonight's discussion, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. Well people, my name is Wassim and I'm your chemistry master teacher right here on this JEE Enthuse channel, yeah? Well, the ones who have not liked the video yet, do like the video, share the video with your friends, and do subscribe to the channel as well, okay? You guys can first of all let me know in the chats if all of you are super duper excited about this particular session, my dear people. Yes? Let me know in the chats if all of you are super duper excited about this particular session. Let me know in the chats, my dear people. That's wonderful, that's great. All right, people. Perfect. Let's get going then. Let's get started with the first question, which is going to be on your screen in 3, 2, 1, and now. This is the first basic and the simple question which is on your screen. I would want you guys to let me know its answer in the chats. I'm looking at your chats only. Let me know fast in the chats. What do you think about this particular question? If we consider that 1/6 in place of 1/12 mass of carbon atom is taken to be the relative atomic mass unit, the mass of 1 mole of a substance will be. What do you think about this particular question, my dear people? What do you think about this particular question? Let me know its answer in the chats. I'm looking at your chats only. What do you think about this particular question? Well, it's a very simple question, right? It's completely a theoretical question, I must say. If you replace 1/12 of mass of carbon to an atom by 1/6 of mass of carbon to an atom, right? The molar mass of a substance, that is going to remain anyways unchanged, right? Molar mass of the substance will remain unchanged if we replace 1/12 mass of carbon to an atom with 1/6 of mass of carbon to an atom, right? So the first question, its answer is going to be option B. This is a very simple and basic question, my dear people, right? So do remember it from now onwards. The mass of 1 mole of the substance, which we call as molar mass of the substance, it is going to remain unchanged when we replace our unit from 1/12 of mass of carbon to an atom to that of 1/6 of mass of carbon to an atom. Very simple and basic this is, right? Let me actually move on to the next question. Look at this particular one, and I'm sure you all can solve this particular question as well. It's a very simple and basic. There is no calculation involved in it, right? Chlorine has 2 isotopes, Cl35 and Cl37. The percentage abundance of Cl35 is 75%. Average atomic mass of chlorine is 35.5. Find the percentage abundance of Cl37, right? I'm sure every one of you can solve this one. It's a very simple and basic one, right? What do you think about this one? Absolutely, people. The answer is going to be 25%. You know, the sum of percentage abundances of all the isotopes of a particular element, that's always 100. If percentage abundance of one isotope is given to us as 75, that simply means the percentage abundance of the another one is simply going to be 25%, right? It's again a very simple and basic question. Perfect. I'm not going to solve this one, right? It's a simpler one. Every one of you can do it on your own. Okay, look at this particular question. Calculate the number of ions in 0.1 moles of AlCl3. What do you think about this one? Calculate the number of ions in 0.1 moles of AlCl3. So how many moles how many ions will be there in 0.1 moles of AlCl3? What do you think about this one? See guys, it's a very simpler one. Well, as per the question, we are given with 0.1 moles of AlCl3, right? So I'm given with the number of moles of AlCl3 as 0.1. This is something which is given to me as per the question, right? If I ask you, how many AlCl3 units will be there? I'll say number of units of AlCl3. It's simply going to be equal to 0.1 multiplied by Avogadro's number. This is something every one of you would be knowing, right? So these many units of AlCl3 we have. Now if you know how this AlCl3 undergoes dissociation, it undergoes dissociation as Al tri positive plus 3 times Cl negative, right? Or I can say 1 mole of AlCl3, it gives 1 plus 3. Or you can say 1 unit of AlCl3 gives 1 plus 3, 4 units, right? I can say 1 unit of AlCl3, it actually gives 4 ions, or I can say it contains 4 ions. If 1 unit of AlCl3 contains 4 ions, so 0.1 Na units of AlCl3 will be containing 4 multiplied by 0.1 Na. The value comes out to be 0.4 Na ions. So these many ions will be present in total in 0.1 moles of AlCl3. So the correct answer of this particular question is absolutely going to be option B, right? Let me know in the chats if it is clear to everyone so that I can move on to one more, my dear people. Let me know in the chats if it is super clear to everyone so that I can move on to one more. Yeah? Perfect. All right, so let's move on to one more question then. This is one more question. Which of the following pair of gases contains the same number of molecules? Which of the following pair of gases contains the same number of molecules, right? So first thing, I'm given with 16 grams of oxygen and 14 grams of nitrogen, right? See guys, the mass of oxygen as per the question, as per the first option, if I select the first option, the mass of oxygen is given to me as 16 grams. And at the same time, let me tell you the mass of nitrogen, it is given to me as 14 grams, right? So first thing which I'll be doing over here, I will be calculating their number of moles. Number of moles of oxygen is simply going to be equal to mass of oxygen divided by molar mass of oxygen. The value comes out to be 0.5, right? Similarly, number of moles of nitrogen is simply going to be equal to mass of nitrogen divided by molar mass of nitrogen. The value comes out to be 0.5. I got the moles of both, right? I got the moles of both. Well, do I need to calculate the moles or molecules? I need to calculate the molecules. How do we convert moles into molecules? We are simply supposed to multiply the moles with the Avogadro's number. I will be getting the number of molecules. So I must say number of molecules of oxygen, right? Number of molecules of oxygen right here is going to be equal to 0.5 multiplied by Avogadro's number. And in the similar way, if I ask you how many molecules of nitrogen will be there, it's again number of moles of nitrogen multiplied by Avogadro's number. So first option is only going to be the correct answer of this particular question. So I must say 16 grams of oxygen and 14 grams of nitrogen, they will be containing same number of molecules which I was supposed to calculate as per the question. Let me know quickly in the chats if it is super clear to everyone so that I can move on to one more. Yes? Let me know quickly, my dear people, if this question is clear to everyone. Fast. Perfect. Let's move on to one more then. This is one more question on your screen. And I'm sure you would have solved this question, right? Because this was once asked long back in your JEE Mains examination. It's a very simple one, but right? Let's see exactly how this question is to be solved and what the question exactly says. Say, at 27 degrees centigrade and 1 atm pressure, a given mixture of O2 and SO2. So basically, let's say I've got the container, and in this container we have got two gases. One is your O2 gas, another one is SO2 gas. So basically there are two gases present in the container. Number one, right? There are two gases present in the container. And as per the question, these gases are in 2:1 volume ratio. Their volume ratio is given to us as 2:1, right? As per the question, the temperature and the pressure of the mixture is kept fixed. I've kept the pressure and temperature of the mixture as constant, as fixed, right? Okay. Now, as per the question, what are we supposed to calculate? We are supposed to calculate the total number of moles present in 20 grams of the mixture. So basically, mass of the gaseous mixture as per the question is given to me as 20 grams. And what am I supposed to calculate? I'm supposed to calculate the total number of moles which will be there in 20 grams of mixture, right? I need to calculate total number of moles which will be there in 20 grams of mixture. I can say total moles present in 20 grams of mixture is simply going to be equal to mass of mixture divided by molar mass of the mixture. What do we call this molar mass of the gaseous mixture as? We call it simply as M average molar mass of the mixture, right? Now people, mass of the mixture is given to me as 20 grams. Now the first thing which I'll be doing, I will be calculating the average molar mass over here. And once I get the average molar mass, I'll put that value into this expression. I'll be exactly getting the total moles present in the mixture. That's all I have to do, right? See now. Let me call this as gas 1, O2. Let me call this as gas 2, this SO2. What is the molar mass of gas 1? What is the molar mass of O2? It is 32 grams per mole. What is the molar mass of SO2, which I call as M2? It is 64 grams per mole, right? Let me call this directly as V1. Let me call this directly as V2. We have got one simple result to calculate the average molar mass of the gaseous mixture, which will be present at constant pressure and temperature. It's simply going to be equal to M1V1 plus M2V2 divided by V1 plus V2, right? So M1 value, as per the question, it's 32. V1 value, that's equal to 2, plus M2 value, that's 64. V2 value, that's 1, divided by V1 plus V2, 2 plus 1, 3. The value comes out to be 128 divided by 3 grams per mole, right? So I got the average molar mass of the gaseous mixture. So the question is done and dusted, right? So number of moles present in the mixture, it's going to be equal to mass of the mixture divided by average molar mass of the mixture, which is 128 divided by 3. That 3 goes up, it's 60 divided by 128. The value will be approximately 0.4 something, right? So 0.468 is basically going to be the correct answer of this particular question. I'm sure this is again clear to everyone, right? Yes, Dinesh, there was some notification regarding BITSAT examination. Well, I think Shreyas sir has already announced that. You checked his video. I think in the morning itself he came live, Shreyas sir, your physics teacher, right? He already gave you the notification of that, I believe. I have not seen that video exactly. Okay. I'm sure this question is perfectly clear to everyone. So let's move on quickly to one more question. The ratio of masses of oxygen and nitrogen. Okay. The ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. The ratio of their molecules will be. Yeah? See, as per the question, the ratio of the masses of oxygen and that of nitrogen. The ratio of masses of oxygen and that of nitrogen is given to us as 1:4, right? So this is something which is given to me as per the question. What am I supposed to calculate? The ratio of their molecules, right? So first of all, what I'll be doing exactly, I will be calculating the ratio of their moles first. I'll be calculating the ratio of their moles. I'll say number of moles of O2 divided by number of moles of N2 will be equal to. Number of moles of O2 is going to be mass of O2 divided by molar mass of O2 whole divided by. Number of moles of N2 is simply going to be mass of N2 divided by molar mass of N2, right? Now people, I can write it simply like this. Mass of O2 divided by mass of N2 multiplied by. It's going to be molar mass of N2 divided by molar mass of O2. Simple calculation, I'm doing nothing else, right? Well, this is the term which is given to me as per the question, WO2 divided by WN2. This is given to me as per the question as 1/4. This is 1/4 multiplied by. Molar mass of N2 is 28 grams per mole. Molar mass of oxygen is 32 grams per mole. So this 4:1, this is 4:7. The value is going to be 7:32. So basically, I got the ratio of the moles. I got the ratio of the moles of the two gases. And let me tell you, the ratio of the moles of the gases is going to be same as that of the ratio of the respective molecules. Whatever is going to be the ratio of the moles, same is going to be the ratio of the molecules. So ratio of the molecules again is going to be 7:32. Let me know quickly in the chats if this question is again clear to you so that I can move on. Yeah? A very simple and basic question this is. Let me know fast in the chats. Perfecto. Wonderful, guys. So let's move on then to one more question. This is one more question on your screen. Let's say exactly how this sort of a question is to be solved. How many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? How many moles of magnesium? This is again the previously asked question in JEE, right? This question has been asked once in your JEE mains, long back, right? I don't remember the year, 2013 or 14, something like that. Okay, see exactly how this sort of a question is to be solved. How many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms, right? If I ask you, in 1 mole of magnesium phosphate, how many moles of oxygen are there? I must say 1 mole of magnesium phosphate, 1 mole of magnesium phosphate, it contains exactly some 4 2s are 8. It contains 8 moles of oxygen atoms, right? It contains 8 moles of oxygen atoms, yeah? Right, people? Or if I just reverse the statement, I can say 8 moles of oxygen atoms, 8 moles of oxygen atoms are present in 1 mole of magnesium phosphate. 1 mole of magnesium phosphate, right? 8 moles of oxygen atoms are present in 1 mole of magnesium phosphate. Can I say 1 mole of oxygen atom will be present in 1 by 8 moles of magnesium phosphate? As simple as that. So can I say 0.25? 0.25 moles of oxygen atoms will be present in 1 by 8 multiplied by 0.25. Instead of 0.25, I can write 1 by 4. It's going to be moles of magnesium phosphate. So 1 divided by 32. These are going to be the moles of magnesium phosphate. These are going to be the moles of magnesium phosphate, which exactly contains 0.25 moles of oxygen atoms, right? So basically we got to know these many moles of magnesium phosphate exactly contains 0.25 moles of oxygen atoms. That's something which I was supposed to calculate. Now you can do a bit of calculation. See 1 by 32. Let me tell you, 1 by 32 value will come out to be 3.125 into 10 raised power what? 10 raised power minus 2, right? 1 by 32 will exactly come out to be this value. Yeah, so it's option B, which is exactly going to be the correct answer of this particular question. So you exactly got to know 0.25 moles of oxygen atoms exactly are going to be present in these many moles of magnesium phosphate. A very simple and basic question this was again, yeah. Let's move on, people, to one more question. Let's move on to one more question. This is a simple reaction that's given to me. How much HCl is needed for the complete reaction with 69.6 grams of what? MnO2. How much HCl is needed for complete reaction with 69.6 grams of MnO2, right? Well, there are many ways by means of which you can solve this question. You can use mole method, you can use mass method. Well, I'll be using mass method into this particular question because by solving this question with the help of mass method, this is going to take lesser time, right? Let's see. If I ask you what is the molar mass of HCl, molar mass of HCl is going to be 36.5 grams, right? 36.5 grams is basically mass of 1 mole of HCl. But do I actually have 1 mole of HCl or 4 moles of HCl? I have 4 moles of HCl. If mass of 1 mole of HCl is 36.5 grams, what is going to be the mass of 4 moles of HCl? It's 4, 5, 20, 4, 6, 20, 4, 26, right? 4, 3, 12, it's going to be 146. So I'll say mass of 4 moles of HCl is simply going to be 146 grams, right? Okay. What is the mass of 1 mole of MnO2? Mass of 1 mole of MnO2 is basically molar mass of MnO2, that is 87 grams, right? Now I'll be simply writing one statement, and the statement is going to be 87 grams of MnO2, 87 grams of MnO2 reacts with 146 grams of what? 146 grams of HCl. As per the stoichiometry of the reaction is concerned, I got to know 87 grams of MnO2 reacts with 146 grams of HCl. So can I say 1 gram of MnO2 reacts with 146 divided by 87 grams of HCl, right? So can I say 69.6 grams of MnO2, 69.6 grams of MnO2 will be reacting with 146 divided by 87 multiplied by 69.6 grams of HCl. So you got to know exactly this is basically the mass of HCl which is reacting with 69.6 grams of MnO2. Now it's going to be your job to do this much of calculation and get the desired answer. That's it, right? So you got to know this is basically going to be the mass of HCl which is needed to completely react with 69.6 grams of MnO2. That's something which I was supposed to calculate. Let me know in the chats if it is super clear to everyone. Let me know in the chats, my dear people. So final answer is going to be 116.8 grams. Let me know in the chats if it is clear to every single guy so that I can move on and talk about a few more questions. Yeah? Let me know fast in the chats. Your chats are stuck. I think the chats are stuck. Oh, now it's fine. Now it's fine. All right, let's move on to one more then. This is one more question, again the simpler one. This is something which I'm giving as the homework. This is a very simple equation, right? You guys can easily solve this one. It's again the equation which is based on the same concept which I gave you a few minutes back. Yeah? This is the equation which I gave you a few minutes back. Let's move on to one more. Let's move on to one more. Let's move on to one more. This is one more question, my dear people. And let's exactly see how do we tackle these sort of questions. See, as per this question is concerned, a gaseous mixture of propane and butane. So basically, we are given with a gaseous mixture of propane and butane, right? So let's say this is the container which contains propane. What is the formula for propane? It is C3H8. It is the formula of propane. And butane. Butane formula is C4H10, right? So we are given with a gaseous mixture which contains propane and butane, yeah? And let me tell you, a gaseous mixture of propane and butane of volume 3 liters. So the volume of this gaseous mixture is given to me as 3 liters, right? On complete combustion produces 10 liters of carbon dioxide. When this gaseous mixture undergoes combustion, it produces how much volume of carbon dioxide? It produces some 10 liters of carbon dioxide, that too at STP. What are we supposed to calculate? We are supposed to calculate the volume of propane and butane in the mixture, right? Let's assume in this mixture, there are some X liters of propane present. So there will be some 3 minus X liters of butane present as well. So in this mixture, I've got some X liters of propane. That's something which I'm assuming. And in the similar way, there will be some 3 minus X liters of butane present in the same container as well, right? Now people, when we do the combustion of this mixture, what is going to happen? When we do the combustion of this particular mixture, what is going to happen? So first of all, C3H8, when it undergoes combustion, it leads to the formation of carbon dioxide, and with this carbon dioxide you get water as well. And in the similar way, when butane will undergo combustion, right, when it will react with oxygen, with the excess of oxygen, it's going to lead to the formation of carbon dioxide, and with this carbon dioxide you will be writing water as well, right? These are the two reactions which will be happening when this gaseous mixture undergoes combustion, right? Now guys, understand, are these reactions balanced or not? These reactions are not at all balanced, right? So let me try to balance these reactions. This is 3, let me make this 3 times. This is 8, let me make this 4 times. This is going to be 5 times. This reaction is balanced. It's a balanced chemical equation now. This is 4, let's make it 4 times. This is 10, let's make it 5 times. This is going to be 4 plus 10 by 4, which is going to be, this is 5, this is 2, 4 2s are 8, 8 5 13, 13 divided by 2, right? So its stoichiometric coefficient is simply 13 by 2. And I assume you guys know how to balance the combustion reactions. If you do not, do have a look over here. If I'll be having a general hydrocarbon like this, if I'll make it to react with the excess of oxygen, it will first of all lead to the formation of carbon dioxide and water, right? Now, there are X carbon atoms, let's make this as X. There are Y hydrogen atoms, let's make this as Y by 2. And the stoichiometric coefficient of oxygen is going to be X plus Y by 4, as simple as that, right? Right, people? So this is basically how you balance the combustion reaction of any organic compound, right? Now see how this sort of equation is to be solved, which is given to you. See guys, as per the question, the stoichiometric coefficient right here is 1 and right here it's 3. Can I say 1 liter of propane gives some 3 liters of carbon dioxide? As simple as that, right? 1 liter of propane gives 3 liters of carbon dioxide. But do I have 1 liter of propane in the container, or we have got some X liters of propane in the container? I must say we have got some X liters of propane in the container. So people, if 1 liter of propane gives 3 liters of carbon dioxide, so can I say X liters of propane are going to produce 3X liters of carbon dioxide? So from this particular reaction, this is going to be the volume of carbon dioxide which will be getting liberated. As simple as that, right? Now we will have a look. The stoichiometric coefficient right here is 1, right here it's 4. Can I say 1 liter of butane gives 4 liters of carbon dioxide? As simple as that, right? As per the stoichiometry, I got to know 1 liter of butane gives 4 liters of carbon dioxide. If 1 liter of butane gives 4 liters of carbon dioxide, so I must say 3 minus X liters of butane are supposed to produce 4 multiplied by 3 minus X liters of carbon dioxide. So basically, this is the volume of carbon dioxide which is being liberated from reaction number 1. This is the volume of carbon dioxide which is being liberated from reaction number 2. And what is the total volume of carbon dioxide which gets liberated? That's given to us as per the question, right? So can I use one simple statement? Can I say volume of carbon dioxide which is liberated from reaction number 1 plus volume of carbon dioxide which is liberated from reaction number 2 should be equal to the total volume of carbon dioxide liberated. That's something which I'll be using, yeah? So I'll be making one equation, volume of carbon dioxide which is getting liberated from reaction number 1, that's 3x. volume of carbon dioxide which is getting liberated from reaction number 2, that is 4 multiplied by 3 minus 6 is equal to total volume of carbon dioxide liberated, that's 10 liters, right? You got one equation, one unknown, the equation is done and dusted, right? See, it's going to be 3x, this is going to be 12, this is going to be minus 4x is equal to 10. So it's going to be minus x is equal to minus 2. So from here, you can say x is equal to 2. And what is x basically? X was the volume of propane in the mixture. So you got to know there are some 2 liters of propane in the mixture, right? If people, there are some 2 liters of propane in the mixture. So how many liters of butane will be there? 3 minus x, 3 minus 2, 1 liter. So there are 2 liters of propane and 1 liter of butane in this container, which I was supposed to calculate. Let me know quickly in the chats if this sort of equation is clear to you so that I can move on to one more. Let me know fast, my dear people. Let me know fast in the chats if this is super clear to everyone so that I can move on to one more. Thank you, Hari. Thank you so much. Perfect, guys. Perfect, perfect. Let's move on then. Let's try to solve a few more questions. See, this is one more question, a very simple and basic basically, right? Calculate the mass of P4O10 when 1.24 grams of P4 reacts with 1.92 grams of oxygen. So first of all, I'm making P4 to react with oxygen. And when P4 is reacting with oxygen, it leads to the formation of what? P4O10. This is something which is given to me as per the question is concerned, right? Now first thing, if I ask you, is this reaction balanced or not? The reaction is not at all balanced. So let's make it as 5 times. Now the reaction is balanced, right? So, am I given with the mass of P4? Absolutely. Am I given with the mass of O2? Absolutely. Right? So, let me first of all calculate the number of moles of P4 which are given to me. Right? It's going to be mass of P4 which is 1.24 divided by molar mass of P4. Potassium has got the molar mass of 31 multiplied by 4. It's going to be 4. It's going to be 124. Right? It's going to be 124. The value comes out to be how much? Right? Let's keep it as such. Let's keep it as such. Right? Let's keep it as such. Perfect. Is it clear, big guys? Right? Or let's write it as 10 raised by minus 2. Right? So basically, these are the number of moles of P4 which are given to me as per the question. Similarly, how many moles of O2 are given to me as per the question? Let me calculate the number of moles of O2. It's going to be equal to mass of O2 given to me as per the question divided by molar mass of O2, which is 32. Can you let me know in the chats what is this value coming out to be? Can anyone let me know fast in the chats how much this value is coming out to be? I'm waiting. Can you let me know fast how much this value is coming out to be? 1.92 divided by 32. Fast, fast people. In the chats, 0.06. Okay. This value is coming out to be 0.06, right? So basically at time t is equal to 0, initially we are starting with how many moles of P4? We are starting with some 0.01 moles of P4. And how many moles of O2 we are starting with? We are starting with 0.06 moles of O2. So this product is going to be 0 at time t is equal to 0 because the reaction has not started yet. I'm saying time t is equal to 0. Initial conditions, the reaction has not started yet. Now, I'm given with the amounts of both the reactants in terms of moles. Whenever you'll be given the equation in which you'll be given with the amounts of all the reactants, the amounts can be in terms of moles, it can be in terms of mass, volume, millimoles, whatever. At that point of time, we use the concept of limiting reagent, right? So first thing which I'll be doing, I'll be identifying exactly which among the two is going to be my limiting reagent. And how do we identify the limiting reagent exactly? We are supposed to divide the given moles of reactants by their respective stoichiometric coefficients, right? It's going to be 0.01 divided by 1. It's going to be 0.06 divided by stoichiometric coefficient 5. The value over here comes out to be 0.01. It's going to be 0.012 something, right? Which value comes out to be lesser? This value comes out to be lesser, right? So this P4 is going to be my limiting reagent. So I first of all identified the limiting reagent, which is this P4. If P4 is a limiting reagent, I must say it will be getting completely consumed in the reaction, right? Now, entire product in this particular reaction will be decided by the limiting reagent. Can I say 1 mole of P4 gives 1 mole of P4O10? So 0.01 moles of P4 will give me 0.01 moles of P4O10. So I exactly got to know the number of moles of P4O10 which are getting formed in the reaction, which is 0.01. But am I supposed to calculate the number of moles of P4O10 or mass of P4O10? I'm supposed to calculate the mass of P4O10, right? Right, people? I'm supposed to calculate the mass of P4O10. How do you convert moles into mass? How do you convert moles into mass? It's simple. I'll be writing mass of P4O10 is simply going to be equal to moles of P4O10 multiplied by molar mass of P4O10. Molar mass of P4O10, how much it comes out to be? 10 oxygen means 320, P4 means 124, right? Was it 124? Yeah, 124. How much it comes out to be? This is 4, this is 4, this is 4, right? Wow, 444. So its molar mass is 444. Perfect. So what was I supposed to calculate? Calculate the mass of P4O10 when 1.24 grams of P4 react with 1.92 grams of oxygen. But no option is matching. How come that is possible? So it is coming out to be approximately 4.4 grams, 4.44 grams. Okay, we did a mistake. Just molar mass of P4O10 is not 444. Wait. There are 10 oxygen atoms, so it's going to be 160, right? It's going to be 160. So the molar mass of it is going to be, this is 4, this is going to be 8, this is going to be 2. So it is basically 284 grams per mole, right? So the final answer is going to be 2.84. 2.84 grams. So we got to know exactly 2.84 grams of P4O10 will be getting formed at the end of the reaction, which is option D. Let me know in the chat if it is clear to everyone so that I can move on. Let me know fast, people, if it is clear to everyone. Let me know fast in the chats if it is super duper clear to everyone. Yeah? Perfect, guys. Just give me a second. Let's move on to the next question. Let's move on to the next question now. Okay, one simple and basic question this is, again based on the limiting reagent concept, right? You can easily solve this sort of equation. We are starting with 0.1 moles of BaCl2, 0.3 moles of Na3PO4. This is going to be 0, this is going to be 0 because I'm writing time t is equal to 0, right? At time t is equal to 0, the reaction has not started yet, basically, right? Now, as I told you a few minutes back, whenever in a reaction, you will be given with the amounts of all the reactants at that point of time. We use the concept of limiting reagent. So again, I'll be using the concept of limiting reagent, right? I'll try to identify first of all which one is the limiting reagent. So divide the given moles of reactants by their respective stoichiometry coefficient. Stoichiometry coefficient is 3, right here it's 2. The value comes out to be around 0.033. The value comes out to be 0.15. Which value is lesser? 0.33. So this is basically your limiting reagent, right? So I got to know which one is the limiting reagent, right? If BaCl2 is the limiting reagent, it would have got completely consumed in the reaction. And you know, your entire product will be decided by the limiting reagent exactly. Yeah? Now, I can say 3 moles of BaCl2 gives 1 mole of Ba3PO4. If 3 moles gives 1 mole, so 1 mole gives 1 by 3 moles. So 0.1 moles gives 1 by 3 multiplied by 0.1. So the value comes out to be 0.1 divided by 3, which is going to be 0.033 moles, right? These are basically the moles of Ba3PO4 whole twice which got formed, right, at the end of the reaction. These are the moles of Ba3PO4 whole twice which got formed at the end of the reaction. Since you got the moles of Ba3PO4 whole twice formed, you are simply supposed to multiply these moles of Ba3PO4 whole twice with the molar mass of this substance. You'll be simply getting the mass of this Ba3PO4 whole twice which is getting formed at the end of the reaction, right? Right, people? So finally, the moles which you are getting, right? Finally, the moles you are getting, you'll be multiplying that with the molar mass, right? You'll be finally getting this as the answer, right? As simple as that. Let's move on. Okay, this is similar sort of question. I would want you guys to do this particular question on your own. This is a similar sort of question, right? I'm not going to solve this one. Or let me solve this one. Or let me solve this one. It's a percentage yield equation. Wait. As per the equation, 0.4 moles of PCl5 combines with 1.8 moles of water. If 65.7 grams of HCl is formed, calculate percentage yield, right? How do we calculate percentage yield, my dear people? There is a simple formula by means of which we calculate percentage yield of the reaction. And that formula is going to be experimental amount divided by expected amount multiplied by 100, right? Have a look. I have already noted its solution. So from the solution, we'll solve this question. This is the reaction, first of all, PCl5 plus water gives HCl plus H3PO4. This is basically the reaction which is given to me, right? Now, at time t is equal to 0, I'm given with how many moles of this? I'm given with 0.4 moles of PCl5. And there are 1.8 moles of water given as well, right? Yes. So, just a second. The terminologies are a little bit shuffled, right? So this 65.7, what is given? 65.7 grams of HCl are produced, right? Calculate the percentage yield of the reaction. Okay. See, I'll be first of all writing percentage yield of the reaction. It's simply going to be experimental amount divided by expected amount multiplied by 100, right? Experimental amount divided by expected amount multiplied by 100, correct? Now guys, have a look. See what all things we are given with. I'm given with 0.4 moles of PCl5. I'm given with 1.8 moles of water as well. I'm given with 1.8 moles of water as well, right? And as per the equation, it's mentioned that 65.7 grams of HCl are produced. 65.7 grams of HCl are produced. Now, first thing which I'll be identifying which one among the two is limiting reagent. So divide these given moles by their respective stoichiometry coefficient. 0.4 divided by 1, 1.4, 1.8 divided by 4, right? Yes. So this values will be coming out to be lesser. So this one is your limiting reagent. So PCl5 is the limiting reagent. You got to know PCl5 is the limiting reagent, right? If PCl5 is the limiting reagent, so can I say 1 mole of PCl5 gives 5 moles of water? 1 mole of PCl5 gives 5 moles of water. So 0.4 moles of PCl5 will be providing these many moles of water. Sorry, these many moles of HCl. So basically 2 moles of HCl are getting formed at the end of the reaction. If you got the moles of HCl formed, multiply it with molar mass of HCl, which is 36.5. So these many grams of HCl are basically getting formed, right? These are basically the grams of HCl which are getting formed as per the stoichiometry of the reaction. So this is something which I call as expected amount. This is something which I call as expected amount, which I got to know by means of stoichiometry. And this one was my experimental amount. As per the equation, 65.7 grams of HCl are getting formed, right? As per the equation. So this is going to be experimental. This is expected. Experimental divided by expected multiplied by 100. The value comes out to be 90%. So yield of this reaction is simply going to be 90%. That's all, right? A simple and basic question. And I'm sure you can easily solve these sort of questions from now onwards. An unknown compound contains 8% sulfur by mass. Calculate the minimum molar mass of compound, right? See, I'll be writing percentage of sulfur in an unknown compound. Percentage of sulfur in an unknown compound. It's given to me as 8. Percentage of sulfur in an unknown compound, it's given to me as 8. See guys, how do I solve these sort of questions? Basically, I have got an unknown compound. As per the equation, this unknown compound contains sulfur, right? This unknown compound contains sulfur, right? And what is the percentage of sulfur in this unknown compound? The percentage of sulfur in this unknown compound is 8, right? Which percentage this is? This is mass percentage of sulfur. So I can say percentage of sulfur in the unknown compound is simply going to be equal to mass of sulfur divided by molar mass divided by molar mass of the unknown compound multiplied by 100, right? This is going to be 8. What is mass of sulfur? What is the molar mass of sulfur? Is 32 grams. Since I need to calculate the minimum molar mass of the unknown compound, the molar mass of this unknown compound can be minimum if there be only one sulfur atom, right? So I'm multiplying it with 1 divided by. I'll be now writing minimum molar mass of the unknown compound, right? Multiplied by 100. This value will be equal to 8. So from here, you can calculate the minimum molar mass, right? You can say minimum molar mass of the unknown compound is going to be equal to 8. This is 4. It's going to be 400, right? So 400 grams per mole is basically the minimum molar mass of the compound, which is option B, right? Again, the simple and the basic one. Right, people? Again, simple and the basic one. Yeah? Simple, you were supposed to use the formula. Mass percentage of sulfur in the compound was given 8%. Percentage of sulfur in the compound will be equal to mass of sulfur in 1 mole of the compound divided by mass of 1 mole of the unknown compound multiplied by 100. That's it. That's the formula which we use in order to solve these sort of questions. Moving on to one more. A similar sort of question this is, right? We have got a compound M dot X times water. It contains 40% water by mass. If the molar mass of M is this much, find X. See guys, again the similar sort of question. Well, percentage of water in the compound is equal to 40. Percentage of water in the compound means mass of water in 1 mole of the compound, which is 18x. Mass of water in 1 mole of the compound, which is 18x, divided by molar mass of the compound, which will be equal to molar mass of this plus 18x, molar mass of this Element is 189 plus 18x. So this is basically the molar mass of whole compound. Multiply it with 100. This value is equal to 40. So you have got one equation, one unknown. Solve this, get the value of x. That's it, right? Simple and basic again. One equation, one unknown, get the value of x. See, percentage of water in this compound was given as 40. What does that mean? That means percentage of water in the compound is going to be equal to mass of water in 1 mole of compound. Mass of water in 1 mole of compound, which is going to be 18 for water multiplied by x, 18x, divided by mass of 1 mole of the compound. That means molar mass of the compound, which is 189 plus 18x multiplied by 100. That's equal to 40. So solve this, get the value of x. That's it, right? So x value finally will come out to be 7 after solving this equation. Perfecto. Moving on to one more. This is one more question in which we are supposed to calculate the percentage purity, right? How do we calculate percentage purity first of all? See, percentage purity is always equal to mass of pure substance divided by mass of impure sample multiplied by 100, right? This is the way by means of which you can calculate percentage purity. Now first thing, the reaction that's given to me, let me write it again. It's H2SO4 plus 2 times NaOH. It gives Na2SO4. With this, you'll be writing 2 times water as well. This is the reaction that's given to me, right? This is the reaction that's given to me. Is this reaction given in the balanced form? Yes, the reaction is given to me in the balanced form, right? As per the question, 5 grams H2SO4 sample. So 5 grams H2SO4 sample, that means this is the mass of impure sample of H2SO4. Requires 4 grams of NaOH. It requires 4 grams of NaOH for the reaction, for the neutralization, right? Calculate the percentage purity of H2SO4. Well, percentage purity of H2SO4 is simply going to be equal. Percentage purity of H2SO4 is simply going to be equal mass of pure H2SO4. Mass of pure H2SO4 divided by mass of impure sample of H2SO4, that's given to me as 5 grams. Right, multiplied with 100. Now, what is the first thing which I'll be doing over here? I will be calculating the mass of pure H2SO4, which will be there in 5 grams of the sample. I will be calculating the mass of pure H2SO4, which will be there in the 5 grams of the sample. And how do I do that? See, molar mass of NaOH 40 grams. 40 grams is the mass of 1 mole of NaOH, but I have 2 moles, so 80 grams, right? Molar mass of H2SO4, 98 grams. That means 98 grams is the mass of 1 mole of H2SO4. As simple as that. Can I say 80 grams of NaOH requires 98 grams of H2SO4 as per the question? Yes. 80 grams requires 98 grams, right? So 1 gram of NaOH will require 98 divided by 80 grams of H2SO4, right? So 1 gram of NaOH requires these many grams of H2SO4. So 4 grams of NaOH requires 98 divided by 80 multiplied by 4 grams of H2SO4. So basically, this is the mass of H2SO4 which is actually participating in the reaction. And which mass participates in the reaction? It's always the pure mass of the substance which participates in the reaction. So this is basically the pure mass of H2SO4. This is 1, this is going to be 20. Right? This is going to be 20, right? It's going to be 49 divided by 10. This value will come out to be 4.9 grams. 4.9 grams of H2SO4. So this is basically the mass of H2SO4 which is actually participating in the reaction. And that mass of H2SO4 which will be actually participating in this particular reaction, that's going to be the pure mass of H2SO4, right? So I'll be calculating the percentage purity of H2SO4 in the sample is equal to pure mass of H2SO4 divided by impure mass of sample multiplied by 100. Solve this term, that's going to be the percentage purity, right? That's going to give you the percentage purity of H2SO4 in the sample. I'm sure it's clear to everyone, right? Perfect, guys. So final answer you'll be getting as 98%. 98% is the final answer of this particular question. Let's move on to one more then. Calculate weight by weight percent of 1.5 molar CH3COH solution whose density is this much. It's a simpler one. There is one direct result which all of you must be knowing. Molarity is equal to 10 multiplied by density of solution multiplied by weight percent of solute divided by molar mass of solute. This is something every one of you would be knowing, right? Well, molarity of the solution, do I need to calculate that? No. Molarity of the solution is given to me as 1.5 is equal to 10 multiplied by density of the solution is given to me as 0.8. Weight by weight percent of solute. Weight by weight percent of solute means weight by weight percent of glucose. I need to calculate, divide by molar mass of solute, molar mass of CH3COH. How much it's going to be? I think it's going to be 60, right? Divide by 60. One equation, one unknown. Just solve it. You'll be getting the weight by weight percent of solute as 11.25. This is the weight by weight percent of solute, right? That means weight by weight percent of glucose in the solution is simply going to be 11.25, which I was supposed to calculate. Simple and basic again. Moving on to one more question. The concentration of sulfuric acid that is peddled commercially is 95% H2SO4 by weight. If the density of this is this much, the molarity of this solution. Again, the similar sort of question, guys, which you'll be solving by the similar formula. Molarity of the solution, right? Molarity of the solution is simply going to be equal 10 multiplied by density of solution. How much that's given? 1.834 multiplied by weight percent of solute, which is 95, right? Divided by molarity of, divided by molar mass of solute. Solute is H2SO4, its molar mass is 98 grams. Just solve this term, get the molarity, that's it. Right? That's it. The question is done and dusted. The similar formula which I gave a few minutes back, that formula you'll be using over here. Look at this particular question. As per the question, the density of the solution prepared by dissolving 120 grams of urea. Well, let me tell you, molar mass of urea, which I'm representing by M2, it is equal to 60 grams per mole, right? Because urea is my solute right now. So I'm dissolving some 120 grams of urea in 1000 grams of water. So this is the mass of solvent. This is the mass of solvent, W1 grams, right? This is the mass of solvent, W1, 1000 grams. What is the mass of urea? Mass of urea, which is mass of solute, that is W2, which is 120 grams, right? Well, the density of the solution is also given to me. Perfect. The molarity of the solution will be. It's a very simple and basic question. Let's see exactly how this sort of equation is to be solved. Well, molarity of the solution is nothing. That is mass of solute in grams multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in milliliters, right? Every one of you, I'm sure, you will be knowing about this one, right? Well, people, mass of solute is given to me as per the question, 120, right? Molar mass of solute, molar mass of urea, we know it, 60 grams. Well, I'm not given with the volume of the solution. So in order to calculate volume of the solution, I'll be needing this parameter of density. I'll write density of solution is equal to 1.15 grams per ml, right? So density of solution is simple. It's going to be mass of solution divided by volume of solution, right? This is basically equal to 1.15. So from here, I can write volume of solution is going to be equal to mass of solution. Mass of solution is going to be mass of solvent plus mass of solute, which is going to be 1120 divided by 1.15, and this value will come out to be 973 milliliters, right? So this is basically the volume of solution. You got the volume of solution. Every single parameter you got. M is equal to W2. W2 is the mass of solute, 120 grams, multiplied by 1000. Molar mass of solute, 60 grams per mole. Volume of solution, 973. When you solve this, the value comes out to be 2.05. So 2.05 is basically going to be the molarity of the solution, which is option D. I'm sure it's again clear to everyone, right? Perfect, guys. Is it clear to everyone? Fast. Let me know quickly in the chats. Well, this is one more question which is based on the direct result, right? Molarity of the solution is given to us. You know the solute, that's KOH. Density of solution is given to you. You need to calculate molarity. There is one direct result which connects molarity and molality, right? You guys must be knowing molality of the solution is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity of the solution multiplied by molar mass of solute. Well, molality of the solution is given to me. This is something I need to calculate. Density of solution is given. This is something I need to calculate. Molar mass of solute you can easily calculate. So one equation, one unknown, every single parameter is given to me. You can easily calculate molarity from here. And let me show it to you. Molarity of the solution will come out to be 9, right? Basically, the result which I gave you, that is the quickest way to solve this question, but its actual way of solving this sort of a question is like this, right? This is the actual way of solving the question. Perfect. But that result, if you remember that, you can solve the question in lesser time, right? So people, this was the last question of the tonight's session. I'm sure you got a lot of things today, right? So with this, I'll be taking a leave. I'll see you guys tomorrow at the same time, yeah? Right? And do let me know if you'll be having any sort of difficulty in understanding the concept, right, in the tonight's session. Do let me know in the comment section of the video, right? Do mention it in the comment section. I'll see you guys tomorrow at the same time. Till then, you take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.